Today we're going to look at some more linear equations. We want you to be able to write the equation of a line using what's called point slope form, and also use slopes of parallel and perpendicular lines to write equations. Positive slopes. Anytime your line is positive, or has a slope that's positive, we say that's going up from left to right, or you go uphill. Negative slope then goes down from left to right. Zero slope means that you're not having any rise or either up or down, so it's horizontal, it goes straight across. And then the last type of slope that you can get is what's called the undefined slope. That means you don't have any run to your line, which forces that to be zero. For example, this is why we call it undefined. If you pick 2 points on this line, say that point and that point, this point is at the point -4, 3. This point is at the point -4, -1. If you find the difference in the run, then there is none. The x does not change, meaning when you find slope, you're going to get 0 on the bottom, and it doesn't. If you subtract, you get 4 on top. But you can't divide by 0 in math, which tells us that this is an undefined slope then. Okay, so those are the different types of slopes that you can get. We talked about before how you find slope. If you have 2 points, you find the difference in the y's over the difference in the x's, your rise over your run. Point slope form is the one we're going to look at next, and that looks like this. Slope is still in there, okay, m is our slope, okay, and then x1 and y1 is one of the points that that line goes through, and it can be any point the line goes through that you can use to get it, okay. So sometimes if you have choices, you can use either one. Let's look at an example. Write the equation in slope-intercept form for the line that has a slope of -2 and passes through the point -5, 6. Okay, so when you're doing this, you can use y equals mx plus b that we did before, and you can get it to come out, or you can use point slope form. We'll show you both first, and then the rest of this notes, we're just going to stick with point slope form. So before, if you were doing it with y equals mx plus b, okay, you could put -2 in for your slope. Okay, this is an xy point, so you can put -5 in for x. You can put -6 in for the y, and then we can solve for the missing y-intercept. Multiply these, you get 10. Subtract 10, and you get -16. So that's our y-intercept. Then you'd have to go back and write the equation out for this, which would be y equals our slope to -2x minus 16. Okay, so that's one way to do it. The other way is with this point slope form. So when you're using point slope form, okay, you start with the point slope equation, and again, plug stuff in that you know. Okay, so here you got still a slope of -2, like they told us before. That's our m, okay, and then the point is our x1, y1. So where x1 is, we're going to put in the point -5, and where y1 is, we're going to put in -6. Now, if we simplify this equation, it should end up being the exact same thing that we got on the left. So we know from before, if you're minusing a negative, that's the same as adding. So let's start with that. So now you got y plus 6 equals -2, x plus 5. Now we can distribute on the right side here. And then our final step here would be to subtract. If we subtract 6 to get rid of that, now we end up with the exact same equation that we did over there of y equals -2x minus 16. Same thing. Okay, so whether you use slope-intercept or point slope, you get the same one. We're just giving you an option of where or what you want to put in. All right, so let's try some more of these using point slope form. Number 2, wants us to write the equation slope-intercept formula. The line goes the slope of -3/2 and passes through -4/1. Okay, so this one you got a slope that is a fraction, but you can still do it the same way. So we're starting with this equation here, and we want to be able to plug in everything where it goes. So we're going to have y minus our y1 is 1 equals our slope is -3/2 x minus, and our x point or x1 is -4. Okay, so now let's go through and simplify. Starting on the right side because there's more to do there. If we got minus and negative, that's the same as plus here. And then we're going to need to distribute. And so we're going to get -3/2 x. -3/2 times 4. Recall if you're multiplying a fraction to a number that's not a fraction, we can put it over 1 to make it that. And then you multiply across, so that'd be -12 over 2, which is the same as -6. Okay, now one last step, we got to add this 1 over, and we have the equation in slope-intercept form of -3/2 x minus 5. Okay, so if you're working with fractions, you should know how to do it. Also, you got a calculator available that can help you assist with those too. All right, third one here. Now, we're switching it a little bit. This problem never gives us the slope. They just give us 2 points that the line passes through. Well, the good thing is we know how to find slope from 2 points. We can use our slope formula here in order to do that. So if we use this, we can figure out what the slope is. So our slope is the difference in our y's, 5 minus 4, over the difference in our x's. Okay, so on that gives us 1 over, we're minusing a negative here, so we want to be adding. Looks like we get a slope of -1/3. Now to find the equation, we got a slope, we got 2 points. It doesn't matter which point you use. You can use either one, and you can get the equation. I'm just going to pick this first one here. You'd get the same thing if you would pick the other point here. It doesn't really matter. Okay, so start with point slope form. Our y1 is going to be 4. Our slope is -1/3 that we just found out. And our x1 is -1. All right, so let's go through. Looks like we got a minus negative there, so that's going to be plus. Distribute. So you get y minus 4 equals -1/3 x. 1 times -1/3 is also going to be -1/3. And last step now, we want to add 4. Okay, now recall when you add fractions, we want to take -1/3 plus 4. You need a common denominator in order to do this. So to get a common denominator, we want 3 on the bottom. So that means we got to also multiply 3 on top. So as a fraction, this is going to be -1/3 plus 12/3. Now that we have a common denominator, we can add the numerators. -1 plus 12 is 11/3. And so our answer in slope-intercept form for this one would be -1/3 x plus 11/3. So we got a fraction. This doesn't cross through right at a whole number on the y-axis. All right, why don't you pause the video and see if you can try doing number 4 here and find out the equation and slope-intercept for that one. All right, let's see how you did here. First thing, looks like you're going to need to find some slope. So subtract the y's over the x's, and you get -4 over -6, which is also the same as 2/3. Now plugging everything into point slope form, and using one of the points, I'll just use the first one again. You got y minus 7, 2/3, x minus 5. Distribute. If you take 2/3 times 5, remember you want to put it over 1, so that's going to be minus 10/3. And then we want to add 7 to this. Adding 7, if you make it into the common denominator, would also be the same as adding 21/3. So our answer is going to be y equals 2/3 x. Negative 10 plus 21 is going to leave us with 11/3. So that's the equation in slope-intercept form. All right, flip to the back of your note sheet. Here, talking about two different types of slopes that are unique parallel lines and perpendicular lines. The thing you should know about parallel lines, as you can see from the picture here, if these lines are slanting in the same direction, they're going to have the same slope. So parallel lines have the same slope. Whatever one slope is, the other is. So if this line right here has a slope of 3/2, then the other line has a slope of 3/2, whatever it might be. Okay, perpendicular lines. Lines that cross at a right angle. You talk about these in geometry. Okay, you can see that little symbol showing that it's a right angle. So if you have perpendicular lines have opposite reciprocal slopes. Okay, so there's two things you got to do to find this slope. You got to take the opposite sign and you got to take the reciprocal. Opposite sign means if one is positive, the other one's going to be negative. So you got to switch the signs. Reciprocal means that you flip the fraction. As an example, if we're looking at these two parallel lines here and we know that one of these lines has a slope of, say, negative 2/3 because this line's slanting down, the other line then would have to be positive because it's slanting up, and the slope that makes it have a right angle would be flipping 2/3 to get 3/2. Okay, that's one example. Let's say you had a slope instead of this of 1/2 for this line slanting up, positive 1/2. Then this line slanting down we know is going to be negative, and if we flip the fraction we would get 2/1, which we could also write as just -2. One last example. What if this line slanting down had a slope of -5? What would be the perpendicular one? Well, it'd be positive again, flip the sign, opposite sign, and we got to flip the fraction. Now, 5 is not a fraction, but you can always make stuff into the fraction by putting it over 1. So then the reciprocal would be 1/5. All right, let's try some of these out where you're doing an equation. Write the equation in slope-intercept form for the line that is parallel to y equals 3x plus 1 and passes through the point 2, 3. Okay, so if we know this line over here has one parallel to it, okay, then we know the slopes have to be the same. So what you got to be able to do is pick out of this equation what the slope is. We know the slope is right there. Our slope is going to be 3. So the parallel line is also going to have a slope of 3. Now, the other part of this, though, is in our new line, what's the new y-intercept? Okay, our other line's not going to have the same y-intercept. Okay, so let's say the graph looks like this. If this is our line y equals 3x plus 1, where the y-intercept's 1 here, our other line's going to have something different. We got to find that other one. Well, here's where our point slope can help us out. We know another point here. So start with your point slope form. Or you could do this with slope intercept form as well. But now we got to put in the information we know. So our slope is 3 because it's parallel. Okay, our point, our x1 and our y1 are listed here. So we got y minus, our y1 is 3, x minus our x1 is 2. This should give us the line now that also has a slope of 3 but a different y-intercept. Distribute and add 3 here and we get 3x. Adding 3 to -6 would give us -3. So that's the line parallel to the other one that also goes through the point over here. And you could get that, show that by graphing as well. Okay, let's try another one of those. Okay, why don't you pause the video and see if you can find, oh, sorry, never mind. Let's do this one together. We'll have you try another one. This one wants us to find the line that is perpendicular. Okay, so now we're doing a little bit different. Remember, perpendicular, that's our opposite reciprocal. So what we got to do is, again, find this slope. Now, we're not going to use the same one, though, because if our line slanting down has a slope of -5/2, we want the perpendicular one. That one's going to be positive reciprocal, +2/5. So in our new line for this one, our slope is going to be 2/5, +2/5, and we also know it goes through the point here of 5, -2. Now put all that information into either slope-intercept form or point-slope form and find that new line. I'm going to use point-slope form since we've talked about slope-intercept already. So we got y minus, our y2 is -2, our slope is 2/5, and our x1 is 5. So now go through, we got some things we can do here, like that turns into adding. We can distribute 2/5 times x, 2/5 times -5. Remember, you can put that over 1. So if we're multiplying here, you can multiply across, or if you see that one's on top, one's on bottom, we can cancel out. So it looks like this equals -2. Now, the last step, subtract 2, and we get y equals 2/5 x minus 4. That would be the perpendicular line to the other one that also goes through that point. Okay, here's another one that's talking about parallel. This one gives us a line that is, this is a linear line, but not in the form that we usually see it. Okay, you got y equals, 5x plus y, and this should be equals, not plus, equals -10. Well, how do we do that? Well, this one we could get in slope-intercept form by subtracting 5x to the other side, getting rid of that. So now we got y equals, now we can't take 10 minus 5x, they're not like terms, but we can just write it as -5x minus 10. So now that is in slope-intercept form. And what that does is let us know our slope here is -5. And if our line's going to be parallel, then we know we want to use same slope. See if you can use this information now to get the equation of that parallel line. All right, let's see what you got. We've used point slope a couple times. I'm going to go back and do this one with slope-intercept form just to show you that again for those of you who like doing it that way. If you put your slope in, which is -5, it would go in for m. The x value here would be 4. Our y value would be 3. We got to find what's the new y-intercept be. Multiplying that is -20. We would need to add 20 since this is negative. And our new y-intercept is 23. If you're doing it this way, though, you can't stop there. You do have to answer the question because they want what's the equation in slope-intercept form. So it'd be y equals, our slope was -5. Our new y-intercept was 23. Okay, you get the same answer if you did it in point slope. This one, number 9. Now we're getting into some equations here that, oh, sorry, I think I skipped one here. Number 8, missed it. Number 8 wants you to do similar problem to the last one, but with perpendicular slope. Okay, I want you to pause the video, see if you can pick out what the perpendicular slope is going to be. All right, let's see what you got. Here's the slope of this line. So if this one had a slope of 1/8, that means our perpendicular slope, this is a symbol for perpendicular here, would be opposite, so negative because the other one's positive, and reciprocal would be 8 over 1, or just negative 8. All right, now pause the video again, see if you can get the equation in slope-intercept form. All right, let's see how you did. Using point-slope form, we'd have y minus 5 equals negative 8, x minus negative 1. Double slash that, distribute, and add 5 to negative 8, and you should have came up with y equals negative 8x minus 3. Okay, make sure when you add 5 to the negative 8 that you get negative 3 and not 13. Okay. All right. We'll end on some graphing ones here. If they want you to graph a line, you want to rewrite that in slope-intercept form. So to get in slope-intercept form, our goal is to get y by itself. So what we want to do is move things to the opposite side. Okay, on this one, I think it'd probably be easiest if we added the 4y over, since there's nothing on the other side. That now gets the y by itself. So now we got 3x plus 8 equals 4y. Now we don't want that 4 there, so we need to divide. So we got to divide everything by 4, and we can get it in slope-intercept form. So now we'd have y equals 3/4 x. Since 4 doesn't divide into 3, we'll leave it as a fraction. 8 divided by 4 is 2. Now to graph, okay, we talked about this. Look at your y-intercept, find where 2 is. Use the slope to get the other points. We're going up 3, right 4, or you could go down 3, left 4, connect them, and we got our line. All right. Why don't you try this last one on your own posit and see what you get. All right, let's see what you got on this one. Probably on this one, the easiest way would be to add 3x to both sides to get y by itself. So now we got y equals 3x minus 2. Okay, looks like you want to start with negative 2 on the y-axis. Now use your slope. Since this slope is a whole number, let's put it over 1. So that our rise is 3, our run is 1, and just keep repeating that, or do the opposite. Connect, and you got your line. All right, you try the practice one.